Good afternoon, everyone. I extend a very warm welcome to everyone who has joined us today for this webinar on India's clean energy transition. In fact, this has been a subject that has been a focus area for Mongabay-India for over 2 years now. This is the eighth episode in the series of webinars that we are organizing on the challenges and opportunities that India's clean energy sector is facing. In fact, in today's program, we want to discuss green hydrogen. It has emerged as a sector which is the latest addition to India's efforts to aggressively pursue renewable energy. In fact, over the past few months, Mongabay has done several stories on the subject. And with green hydrogen emerging as an attractive and viable technology, which has received tremendous support both from the government and the industry, I think it's a subject that needs more clarity. Within no time, I was just remembering that within no time, it is turning out to be a key component of our renewable targets. And if I remember right, the government has even announced the production of around 5 million tons of green hydrogen by 2030. So during today's webinar, we are going to try and examine the questions about the feasibility of green hydrogen. We will discuss the importance of green hydrogen in India's energy transition story. We'll talk about the cost competitiveness. We'll talk about how industry is prepared and the impact green hydrogen's advent can be on Indian industry as well as India's renewable energy sector. So we will talk about all these. We'll talk also about the concerns that are there about green hydrogen and how viable it is. To talk about this and take this conversation forward, we have three eminent panelists today with us. We have Mr. Shirish S. Garud. He is a director and senior fellow at the Energy and Resources Institute, Delhi. He has more than 3 decades of experience in the renewable energy sector. He's a well-known specialist in renewable energy technologies, solar, wind, energy planning, renewable energy policy studies. In fact, he has a rich experience in solar and wind resource assessment, technology development, deployment, policy, and regulatory studies. He's also the member of the technical committee of the Bureau of Indian Standards for Solar and Thermal. His current research interests include hydrogen economy, solar biomass, hybrid drying systems for rural areas, and microgrids for rural applications. Welcome, Mr. Garud. Thank you so much for joining us. We also have Mr. Parthadev with us. He's leading the next phase of ACME's vision to grow the green hydrogen and green ammonia business to a scale of 10 million tons per annum by 2030. He is in fact ACME is in fact a key component, a key player in the green hydrogen sector. So while maintaining the highest levels of safety, sustainability, and governance, Parthadev almost has 3 decades of experience in executing the state-of-the-art mega world-class energy projects. He has a rich experience in working the fossil fuels, and in fact, what we are hoping that with his experience from both fossil fuel sector and green energy, it will be a good understanding for the audience and for us to understand how green hydrogen as a sector is going to or can impact the industry. Just to tell a little bit more about him, he has worked extensively across geographies as well. It's not just India. He's worked in Middle East and India and some parts of Europe as well. Thank you, Mr. Dev, for joining us today. Last but not least, we have Professor Ashish Garg, who is the head of the Department of Sustainable Energy Engineering at the Indian Institute of Technology, Kanpur. His research interests include energy materials and devices such as solar photovoltaics, hydrogen and batteries, energy policy, climate solutions, and developing solutions toward carbon neutrality and net zero. So in fact, when I was during my conversation with him, I realized that he is actually the good poster boy for us as far as the renewable sector is concerned, and he can talk about all the buzzwords that are there today. Just to tell a little bit more about him, he's an engineer by training and is passionate about environmental cause and sustainability. So I am hoping that we will have a very good mix of perspectives from both experts and industry side. Before I go forward, I just want to clarify the format once again. Also for it will help in clarifying it to our audience. We will start with each panelist and request them to share the perspective for 5 to 7 minutes each. And once they are done with the introductory remarks, then we'll have a small discussion with the panelists, which will be moderated by me. And then after the discussion, we'll take questions from the audience. So I encourage all of the people who are listening to us and attending the webinar to share your comments in the chat box and the questions. And before I invite the panelists, I just like to say that to the audience that we are very open to hearing the questions. And once you put the question in the chat box, we'll take it in the last section. So let me not take more time. I have already taken a lot. I'll invite Mr. Garud from Terry to kickstart the discussion and take us through this green hydrogen webinar. start this journey of this webinar and tell us a little more about this sector and what are the challenges and opportunities the sector provides to us today.
Thank you, Mayank, for excellent introduction, and also Mongabay for giving me this opportunity. I think it is apt to start with the why we call hydrogen as a green. Hydrogen is a colorless gas, and one of the most abundant, rather it is the most abundant available element in the universe. All the stars are made out of hydrogen, and what we are talking hydrogen and why suddenly it has become a buzzword and in the recent past. So if you really look back a little bit, the hydrogen was one of the talked about after the 1973 oil crisis, when everybody started looking for alternatives to the oil, and the renewables and hydrogen was one of the important thing. Why hydrogen? Because hydrogen has it can act as a fuel, replacing other fuels. It can also, with its chemical properties, it can act as a chemical agent in many of the chemical processes like steel manufacturing, etc. And it is also it can also be energy storage, something which can store energy particularly, and can convert it into electricity very easily. And that is why the hydrogen has a multiple use. And hydrogen is being thought as an alternative to oil economy or coal economy, mainly from the climate change perspective. And as you know, after the Paris Accord in COP26, there is a lot of discussions going on, and subsequently many countries have announced zero emission targets. And in recent COP26, our Honorable Prime Minister also announced the target for net zero emission by 2070 for India. Now, if one has to really take it seriously and go for net zero emission pathway, the alternatives are very limited. One of the alternatives is to electrify many processes and where energy is used. But currently we use about 16-17% electricity as part of total energy consumption, primary energy consumption. But if we really want to use electricity everywhere, it is not possible. The second, because emissions are mainly coming from energy sector because of burning of fossil fuels and coal, including coal. So when one is looking at renewable electricity or renewable energy, that is one major way of replacing fossil fuel. But there's another way. Another major is where how do you replace the aviation fuel or fuel used in large quantities in shipping, international shipping or international aviation, or even in the transport sector. Electric vehicle is one of the options, but it has limitations. Batteries have limited capacity, and weight to energy ratio is not very attractive for large scale, to cover large distances. So frequent, charging is required. So all these factors make that you need some alternative for fossil fuel and electricity, and that alternative is provided by the hydrogen. But hydrogen, as you know, is currently produced using steam reforming process of natural gas. So natural gas is methane, basically CH4, and it is converted into carbon dioxide and hydrogen using steam reforming process, which is an established process in the industries like refineries and fertilizer industries. But that emits a lot of carbon dioxide. About 8 to 10 kg of carbon dioxide is emitted per kg of hydrogen. So that now that is something which is not going to reduce the emissions. So what we call that hydrogen is a gray hydrogen because it is associated with the carbon dioxide emissions. When we, if we can capture those emissions and through carbon capture utilization and storage technology, CCUS, commonly known as CCUS in technical parlance, then we can reduce the carbon emissions from 8 to 10 to about 4 or less than 4 kg per kg of hydrogen. Although there will be some emissions, but it can be reduced. And hence that kind of hydrogen produced with these processes, with CCUS technology, is called as a blue hydrogen. But if we produce hydrogen through electrolysis using renewable energy, where no carbon emissions are involved, or through say bioenergy or biomass conversion through biomass gasification and other technologies, then that is called as a green hydrogen because it is devoid of CO2 emissions at all in the manufacturing processes. So that is called as a green hydrogen. So to generate green hydrogen, we need to use renewable electricity or biomass or other green energy sources like maybe municipal solid waste through biogas route, through algal conversion, etc. So that is so this is something which is, and this hydrogen can then be used in transport sector for powering the vehicles, which will use some technology called fuel cell, which converts hydrogen and oxygen into electricity and water. We can also use this hydrogen in industries like steel industry for reduction processes where carbon-based reduction process is replaced using hydrogen-based processes. We can use it in steel industry, use it in cement industry, or use it in fertilizer industry, where hydrogen is one of the input materials, and many other chemical industries. So the whole idea of emission reduction or net zero emissions is driving this new hydrogen economy, and across many sectors we can use it. And so this is where we are now. We as far as India is concerned, we started some activity in hydrogen after 1973 oil shock along with renewables, but major thrust was on research and development. In 2006, government Ministry of New and Renewable Energy produced what is called as a hydrogen roadmap 2020, which was supposed to have a lot of activities going on, out of which only research activities started, but on ground implementation was not much there. In 2016, this roadmap was reviewed under a experts committee under chairmanship of Professor Kasturirangan, and that committee again recommended some pathways for research, some pathways for demonstration projects, etc. Still not much was happening till 2021, when the Honorable Prime Minister announced his vision of hydrogen economy, and later on, again new work started for hydrogen policy and hydrogen mission document, which is still under process of preparation, and there are a couple of drafts prepared. But meanwhile, the government started giving budgetary allocation for hydrogen related research. Department of Science and Technology with many institutions like IITs and all have been doing a lot of R&D. The public sector companies like NTPC, BHEL, IOCL have been working on demonstration projects, on research projects, on pilot projects. And now recently we have some announcements from major industrial groups like Reliance and Adani's to have major investments in hydrogen value chain. So this is something which is happening in in the recent past, and which is quite encouraging. The challenges are many. I think I will cover that little later, but I'll stop here now, and back to you, Mayank.
Thank you so much, Mr. Garud, for sharing this perspective. In fact, I'm sure anybody who has no idea about green hydrogen can listen to this and understand the basics. So thank you so much for covering that for us. Now I'll go to Professor Garg. Professor Garg, IITs are considered the fountainhead of a lot of, like, not just IIT, a lot of research institutions are considered the fountainhead of how ideas can be brought into reality and how, if we want, can show a path that how it can be scaled up. So I'll just request you to take this discussion forward and talk about what do you think of the green hydrogen and the possibilities that India has for as far as this sector is concerned. Thank you so much.
Thank you, Mayank, and thanks to Mongabay for having me here. Hydrogen, indeed, as all of us know, that hydrogen is something which has come into our discussions in about last 5-10 years. In fact, if you look at the numbers before 2019, there was hardly much discussion on hydrogen, but since 2019, hydrogen has suddenly become a really talked about matter, especially the green hydrogen. In fact, when we talk of hydrogen, hydrogen is important because hydrogen as a fuel can give us energy which no other fuel on earth can give. So for example, just to give you a number, if you talk of gasoline or diesel, they can give you energy of the order of per kg energy, it could be of the order of 40 to 50 megajoules. But if you talk of hydrogen, this number is close to 110, 120. Very large amount of energy is present in hydrogen, and it is something which is not whose byproduct, when you burn it in various operations, it's water. So as a result, it's very exciting because when you convert hydrogen, it reacts with oxygen and it gives you water. We are mostly aware of 3 forms of hydrogen, which is gray, blue, and green, which Mr. Garud already talked about. But there are about 6 to 7 forms of hydrogen. There is something called as black or brown hydrogen. There is something called as pink hydrogen. There is something called as turquoise hydrogen. Depending upon how you make it and how you capture the carbon, there are different names of hydrogen. So while hydrogen has excellent energy density, the problem with hydrogen is hydrogen also is very light gas. So the volumetric density of hydrogen, while per kg hydrogen can give you a lot of energy, per unit volume, the amount of energy that you can get is not very large. That creates a serious problem in storing hydrogen because you need to pressurize hydrogen at very high pressures, and that storing hydrogen. So not only generation is an issue, which I'll come to a little later, what the issues are, but along with generation, generation is not only sufficient part of the whole hydrogen ecosystem. Another important part of hydrogen ecosystem is how to store green hydrogen. Then how do you transport hydrogen? All these components have to be handled and addressed together in order to have a complete ecosystem of green hydrogen. So if you, as the previous speaker talked about, hydrogen can be used for electricity generation. Hydrogen can be used for utilization in a variety of industries. Hydrogen can be used for transportation. But to make hydrogen also we need electricity. So that is where the issue is. How do you make hydrogen? And green hydrogen is the one which is made using renewable sources, because when you make hydrogen using steam methane reforming or any other process, you basically emit carbon dioxide. And this carbon dioxide is not acceptable if we want to move towards carbon neutrality. And this is where a lot of focus is on producing hydrogen from renewable energy methods. So one of the important cog in the whole hydrogen wheel is the cost of electricity that we get from renewable energy sources. So this is where solar is important, wind is important, and any other source of electricity which can provide electricity renewably and at lower cost. That is why hydrogen is expensive, because hydrogen, the sources from which you get electricity, they themselves aren't very cheap at the moment. Although solar cost has gone down, but there are a lot of hidden costs and it's not really cheap as such. So if you look at the advantages of hydrogen, for example, I'll give you a simple figure. We all run our cars on petrol. 1 liter of petrol, which is 1 liter of 1 kg of petrol would be about 1.3 liter or 1.4 liter of petrol, considering the density of about 0.7 or so. So 1 kg of petrol can drive our car to about 30 kilometers, 25-30 kilometers. And we know how much a petrol costs. Petrol costs is about 110 rupees per liter. But if you talk about hydrogen, right now the cost of hydrogen is 1,000 rupees per kg or so. And the latest fuel cell cars, if you use 1 kg of hydrogen, the amount of power that you can generate, which is twice to that of petrol. So petrol produces 15 kilowatt hour per kg, but hydrogen produces 33 kilowatts per hour per kg. So basically you can run larger mileage. So, and 1 kg of hydrogen can give you about 97 to 100, 110 or 105 kilometer, which is about 5 liters of petrol. So essentially, mileage wise, hydrogen is excellent. But the problem is cost. Right now, it is 1,000 rupees per kg. The question is, can we make it 100 rupees per kg? So what are the bottlenecks? The bottlenecks are hydrogen is primarily produced using electrolysis process. And electrolysis, what is the electrolysis process? All you require is basically 2 electrodes and electrolyte. And you need to have a chemical reaction by applying electric field, which gives rise to hydrogen. This is the simple layman explanation of production of hydrogen. It's all very simple, but this is where the devil lies. The cost of materials that are used in producing hydrogen are terribly expensive. For example, we use iridium as a catalyst. Iridium is a very expensive catalyst. It is a group of platinum group metals. Platinum, we all know. I mean, our wives buy jewelries and gold and platinum, how expensive they are. So iridium is no longer cheap. Iridium is quite expensive. Another thing which is used quite extensively in this is titanium or titanium oxide. They're also not very cheap materials. Not only this, the scaling up issues are tremendous in hydrogen production. So green hydrogen can be viable. It's a very good alternative to gray hydrogen or to blue hydrogen. Blue hydrogen requires you to sequester carbon by using methods, either you can have underground storage, or you can have storage in the form of other materials, or you can have bio storage. So variety of possibilities are there to store carbon. So blue hydrogen is better than gray hydrogen, but it is inferior to green hydrogen. So green hydrogen requires us to work on primarily on designing good materials, good architectures, having capability to scale up in order to give us green hydrogen, which is cheap. Also, the issue at the moment in green hydrogen lies is scalability. A scalability issue is a major issue. Right now, the major plants that operate in the world, they are very small. They are nowhere close to 100 megawatts or 200 megawatts or 500 megawatts. We are still talking about few tens of megawatts, which is nowhere close to the requirement that we have. So there are immense challenges in terms of hydrogen. I will stop here. I'll probably come back to a little later if there are more technical questions involved. I'll now pass on to the next speaker. Thank you.
Thank you so much, Professor Garg, for your passionate conversation. And in fact, I'll tell you very honestly, you have actually touched upon a couple of questions that I have for the session later on, like for the moderator session. We'll come to that, especially about the automobile sector. Thank you. Now I'll invite Mr. Day to talk from his rich experience of the fossil fuel industry and how he's now with ACME, a renewable energy company, how he's handling and how the industry is looking at green hydrogen and the opportunities this sector is providing, or the challenges that it is posing. Mr. Day, the floor is yours.
Hi, thank you very much, Mayank. And let me thank Mongabay-India for organizing such an event. And I'm extremely grateful to be within Mr. Shirish and Professor Garg. It's like an education for me, going back to school and understanding and knowing the history of it with respect to India and with respect to hydrogen as an element, basically. And I would like to give you a little bit of a perspective from the industry point of view. Very, very essential elements has been covered by the earlier panelists. Let me tell you a little bit about ACME, very brief. We have been into solar all this time, operating, setting up, developing plants in India in large number all across. My chairman, Mr. Manoj Upadhyay, has taken a step to set up the first green hydrogen, fully integrated green hydrogen plant in Bikaner in Rajasthan, which is existing, where you can go and see green molecules being produced. And it is a 50-ton capacity plant per day currently. And we are internally as an organization developing the strengths to really produce a green hydrogen, green ammonia plant. And the development of it, there are a lot of renowned people who has congregated together towards this mission, and we are the first in India to go offshore, and that is in Oman, to develop the first plant which is coming up, which is a 300-ton plant in Oman, in the east coast of Oman, and scaling it up to 3,000 tons. Yes, the challenges which has been mentioned by Professor are all in our mind. We are working and we are taking a very step-by-step, sort of a step to move towards that, fully mindful of the fact that it is something new, although hydrogen is known all around the world, but it's something new. And every step has certain, we have to overcome certain technical execution related obstacles, operational related obstacles. We are aware of those. And hopefully with the grace of everyone, with our hard work and whatever research is happening today in the academia and in the R&D world, will help us bridge those gaps and come up with a commercially viable plant, basically. Briefly, as the subject says, where we are in India on the green hydrogen map, I believe we are well placed actually. If you see the hype, the hope, and the hard truths, we are all aware of those basically. And all the functionaries within the space is working in tandem. So if you say from the government, the Honorable Prime Minister is driving it from the top, the regulatory framework, the industry body, both the private and the public. The public, if you take the name of IOCL, NTPC, they are driving it. From the private perspective, it is Reliance and the Adanis, the big wigs, and we also are chipping in with meaningful steps into it, basically. If you see, the public advocacies are working very, very hard. They're burning the midnight oil, trying to bring up all the elements of it from the regulatory perspective, social perspective onto the table. Financial institutions play a very important role here. There are steps being taken where a green investment is being made as an element of within the banks and the public finance institutions, basically, so that we can get finance which are necessary, basically the debt financing. And the academia is playing a huge role. Recently, we have heard L&T tying up with IIT Delhi for the further research, and there has been other institutions who are doing the same. And the technological elements of it, the hydrogen storage and the electrolyzer development, which Professor has touched briefly. So I believe all of it is working in tandem. And it's not only in paper. People are trying out things. They're going for business ventures. They're setting up plans. So I believe it's a good time in the Indian economy, in the Indian space. And there are maybe 20 other countries doing the same out of 33 who have actually gone ahead with the hydrogen mission. Actually, 20 of them are actively pursuing. And I believe we will be seeing a good outcome in over the next 4 to 5 years, and 2030, the targets, and 2050 targets looks to be, I'm not telling we will be, I cannot say with certainty, I'm no one in this thing, but the way we are going, we have taken the right kind of a leap, basically. Now, from the Indian perspective, if you look at it, actually, the decarbonizing the economy, reducing import dependency, and achieving energy security stands out in front. So it is no more a choice, basically, that we have fossils, we have some other forms of energy, and today we can do away with this and go at our pace. I believe it's, if you consider these three elements, I think there is a drive, there is a need that we go aggressively to curb these three, the main constituents which are going to hurt us in one way or the other if you don't take care of us. Now, from the overall perspective of the net zero, clean economy, green hydrogen, I have identified from my perspective, there are 5 pillars which are the governing pillars, basically, which will really determine of where we go from here. As I said earlier, the first one is the government policies, regulatory norms, and the society at large. At some point in time, it will come into play, the social part of it, basically. The next part would be, we need to have money, we need finance and investments, we need to have mandates within the banks, within the financial institutions who could draw money for green projects specifically. Basically, there has to be, I believe there are talks, there are certain financial institutions and banks who are already doing this. So that is one element of it which brings the technology aspects well touched by Professor, both upstream and downstream part of it. Yes, solar is doing, we have done a great deal in solar in trying to draw down the price, but still if we have to get to say a $1 per kg of hydrogen, there's a lot of work to be done actually. Now, the other aspect is, which has been touched also, is the electrolyzer. It guzzles almost 90% of the electricity what is required for production of hydrogen. So electrolyzer optimization, the technology related to alkaline, related to PEM and the solid oxides. Alkaline may be the most prevalent one basically, but PEM and solid oxides, still we are in the evolution, and still there are active organizations around the world who are looking at improving and bringing around more and more efficiency into the system so that we can produce hydrogen with lesser amount of energy, hence the cost. And also there are a lot of manufacturing units being planned in low cost, high-tech environment. And when I say high-tech, low-cost environment, it is where we are sitting today in India. So this is something which we have a great opportunity. We are in the cusp of really making a revolution in terms of energy development, in cleaning out the mess where we are today, basically. And I think we all should take it with, we should grab it and take the opportunity and move forward. The other aspect is the market and the industry transition. What we are seeing is that to move into a larger scale of hydrogen consumption, we have to go to hard to abate industry like the cement, the steel, and shipping. Now, these I personally believe these are not going to happen immediately. It will take some time when we get into the groove. But yes, these are our far-fetched real bets actually, where if we can enter into those industries, then yes, we can say it's a success basically. And while putting all these things together, the last element would be the business model. Now, with respect to business model, since I have come from oil and gas environment and the fossil fuel environment, I believe the business model is already existing. We just need to tweak a little bit of it and make it happen. So adapting to the business model is something which we have to work. We are at the early days now, trying to fight through the viability part of it, the finance part of it, the understanding the technology part of it. But very soon we have to get into the business model when we get into the commercial mode. So in brief, these are the 5 elements I believe which will drive. And there are many other things we can talk. We have 1.5 hours, very precious 1.5 hours. So I would ask all of us to join together and contribute. And I'm available for more discussions and as we go along. Thank you very much.
Thank you, Mr. Day. In fact, I think this sets the stage very well for the next session that we're going to discuss in a little bit more detail. In fact, all 3 of you have touched upon the points, some of the points that are there in my questions now. And I feel that, I'm on the right track. I'm studying the sector properly and I'm on the right track. So great. Let's kick it off. Thank you, all 3 of you, for these valuable points. I just want to start from a very simple, basic question. I'll divide that question in 2. One, that India is already clocking around 8% of the hydrogen that is being produced annually across the world right now. And we have something around 70 million tons of hydrogen that is being produced globally. We are producing around 8% already. So as far as that is concerned, do you think that is India ready to scale it up? That is 1. And 2, how critical it is going to be for India's energy transition story, which is the buzzword, the energy transition that we have been talking about. So how critical it is going to be, and is India ready for this revolution? And I'll request any of you to kick off the discussion. Any of you wants to take it up?
If I'm allowed to do it.
Please start, and then we'll go to Mr.
Yeah. What I'm trying to say is that I think the question is how fast we can start it actually. Not whether we are ready. We have no option but to do it basically, and we are already there. And there are multitude of avenues available where we can do. We have this skilled workforce, we have the government mindset, we have the business environment basically, and we have the understanding of the technology, and we have avenues where this can be put into use basically. And I think we are fully geared up to this. I myself, I'm eager to see how quickly we start commercially producing, and I'm quite mindful of the criticality of the hydrogen as such in terms of technology, production, and putting it in use basically. It's not so simple. I don't want to simplify this, but I think we are in a grand manner, we are ready to do it basically.
Mr. Garud, do you want to take that up?
I fully agree with him that we are ready to go for it. If you look at the current hydrogen production, it is, either in the, most of it is with fertilizer and refineries, which need hydrogen as a part of their processes. And the hydrogen, and of course, there are some chloralkali and other industries which produce hydrogen as a byproduct also in some of the cases. But all these processes are again based on the steam methane reformation SMR processes, which are emitting processes. When we are looking at energy transition, the first step is to make these industries ready for the next, for this transition, for adopting green hydrogen. And one of the major steps in that process is started by the government recently by announcing the hydrogen policy, a part of overall policy infrastructure, policy and regulatory structure, which allowed the hydrogen production by using electricity through the renewable electricity, which is generated off-site by using the interstate transmission lines, ISTS connection, without paying without any ISTS charges. And that means there will be a saving of at least ₹1 or so on the cost of electricity when it is produced. And this is for the next 25 years. So there is a big boost for hydrogen generation in premises for these companies. And this is, I think, is one of the big starting point as far as the India is concerned for green hydrogen. And the other initiative which is under consideration of the government is to make the green hydrogen utilization in these industries as a mandatory, something which is like renewable purchase obligation. So if it is like green hydrogen obligation, then the industries will create some market for hydrogen, even if it is expensive. So once that market is created, then scaling up will happen. Because these industries need huge amount of hydrogen at one place. So that means the infrastructure development is easier. Utilization of that infrastructure is also on a round-the-clock basis. So more utilization. So you have better returns from the investments, and that will set the ball rolling. And then subsequently, other sectors like shipping, transportation, or power generation, etc., can come in picture in a certain time frame. So I think that is the way it will likely to move.
Thank you, Mr. Garud. Thank you. That helps us a lot. Professor Garg, I want to come to you because I remember in your points when you mentioned, you talked about the cost competitive, like how cost effective. So I want to start with that how cost competitive, how cost effective this sector could be. That is one. And is there a way that India can look at to bring down the cost? Obviously, scale is one, but is there any other way that we can look at the cost of producing, like we can bring down this cost of producing green hydrogen a little down in the short run as well as long run?
See, right now, if you look at the hydrogen production process, if you look at the green hydrogen, I'm not talking of blue hydrogen or gray hydrogen. In the context of green hydrogen,
a little loud, sorry.
Am I audible?
Yes.
Yeah.
So in the context of hydrogen production, we use electrolysis process, as I said, and there are right now most people have traditionally used alkaline-based systems which use potassium hydroxide as electrolyte, but those have problems with respect to their efficiency. The distance between electrodes is too large. As a result, they are not very good choice. On the other hand, the PEM-based electrolyzers, the polymer electrolyte membrane-based electrolyzers, or proton exchange membrane-based electrolyzers, they are very good electrolyzers because the distance between electrodes is very small. As a result, the performance is very good. The problem with these electrolyzers is the scalability at the moment. So, and also most of these electrolyzers are produced right now in Europe. Europe is the leading authority on electrolyzers. So if India really is going to bank only on purchasing these electrolyzers from abroad, then it is not going to play out well. We have to develop a strategy for making these electrolyzers and the materials. Electrolyzers do not come standalone. There are a lot of components of electrolyzers which have to be manufactured domestically, and right now it is important because of geopolitics as well. There is a geopolitics which is playing out in Europe, and India has complicated role in this. So looking at all these factors and also the costs involved, it would be wise for India to produce various components of electrolyzer as well as electrolyzer within India. Now, so that is one aspect of it. And the metals that we use right now here, they are, noble metals. Noble metal manufacturing is not easy by any means. And India unfortunately is not a great manufacturer of these metals also. These metals also come from abroad. So manufacturing capability of these materials also become important. The support electronics, the mechanical engineering systems, the chemical engineering systems, all of that. So what I'm trying to say is that when you develop a technology in-house, you must have an ecosystem for developing the peripheral components. Unless you do that, segment of your manufacturing capability is dependent upon imports, and those will come back to hurt you at some point. And in this, material is very important issue. So I think India should focus on manufacturing different components of electrolyzers within the country, including the materials. Then only we will be able to make it cost effective. Otherwise, we'll be reliant on importing these electrolyzers from Norway or from another country, and that will not really be. I mean, you can offset some of these costs perhaps by providing certain subsidies or certain financial incentives, but is that going to be sustainable in the long run? I think no. We need to have domestic manufacturing capabilities, not only in manufacturing, but also remember, it is not just about producing hydrogen. It is also about how do you transport hydrogen? Do you have pipelines which can withstand the corrosion caused by hydrogen? Hydrogen is an element which is a very small element. It diffuses through the metal very easily. It causes embrittlement, which makes the metal weak. So the question is, the pipelines that you have for carrying ammonia or for liquid or for natural gas or for another petroleum product, are they going to withstand the attack of hydrogen? We haven't done those studies. So we need, I'm not saying we can't do that, but I think we should have a strategy to do this in order to become a global player. Similarly, hydrogen storage. Hydrogen storage is very important because you need to pressurize hydrogen and store it at high pressure so that you can have high volumetric capacity. In order to do that, R&D and domestic manufacturing of these materials is also important. So what I'm coming to at is, India can become a global player and a very important player, because we not only we can supply to other people, we also have heavy domestic need. But we need to make an ecosystem, end-to-end ecosystem, which is with manufacturers each and every component, so that we can do it domestically. That will be the win for this country.
In fact, this reminds me that this is the age-old problem, as you started your introductory remarks, that this is the age-old problem, that we know what has to be done, whether we are going to create that ecosystem, whether we are going to follow and walk to that, because our renewable sector right now is completely very important.
And another thing which I will come to is, sorry, I just wanted to, I remembered one point which I did not address. I'm sorry to intervene.
Please.
Every manufacturing industry in a sector requires qualified manpower or human resources. Let's not call it manpower, it is human resources. Now, these human resources, where do they come from? They come from educational institutions, which means you have to foster education and R&D and skill development of our people to serve this sector if we want to achieve the goal of that 500 gigawatts by 2030. Right now, India has serious shortage of skilled electrical engineers, mechanical engineers, really good quality. Many companies have complained that engineering graduates that India produces are not of good quality. Maybe because most of good quality graduates go to IT and consulting and banking sectors. I'm not saying that the boys are bad or girls are bad. Students are good. It's just that we have to create that broad-based ecosystem which can produce that supply of graduates. And same is true for hydrogen manufacturing sector. We are going to need a lot of engineers, a lot of mechanical engineers, a lot of chemical engineers, a lot of electrical and materials engineers. We should make a system to produce these. So all of these things are linked. Maybe you can't develop the technology without having quality manpower.
That will certainly be music to, I'm sure, to law.
Yeah, if I can add to what Professor was mentioning, I believe the days have come when mechanical, electrical and chemical engineers will be again in demand, actually, because the IT storm has taken away everything. And now we have a life and death situation with the net zero and the climate change. And I believe we'll have. Just to add to what you said, Professor, yes, we need to develop the ecosystem. But if you see, the process has started right from the government level, from the helm, actually. If you see offering PLIs, allocating lands in the special economic zones, getting finance, collaboration between the academia and the industry, then collaboration between the European companies and the Indian companies coming together for the manufacturing of electrolyzers. Then our largest conglomerate manufacturing company venturing into manufacturing of electrolyzers. I believe the puzzle is, we have commenced the process of solving the puzzle, actually. And I want to remain very, very positive about the fact that, yes, the electrolyzers, no doubt, is something critical, because it takes away everything what goes into it, basically. And I believe all of it is coming into play in the industrial and the commercial setup. Yes, it cannot be done with a pressing of a button or clicking a finger or something like that. It's not like that, but it is happening. The other aspect is hydrogen. We cannot expect, with the infrastructure we have around, I believe, 20,000 kilometers of pipelines, and 15,000 is still in construction at this stage. We have the hydrocarbon lines which are available. I believe to start with hydrogen, we have to start with blending 2%, 3%, 8%, and see how it is, because hydrogen, with the metallurgy and with the kind of fittings, the construction methodology, the welding, the radiography, it's a long way to have it 100%. But I think there are avenues, and this is what is being done in IOCL Mathura and all, basically, where the blending is the first step, basically. And that's how we move into it in a progressive manner. And then we attain the highest levels, basically. I just want to remain positive that, yes, no doubt it's, and the fact is that we recognize the criticality of it. And that is very important. Just what happened, we were earlier speaking about the battery powered scooters, basically. We had some incidents. People want to get into the market and start counting the eggs, basically. I think there's a process in the technical system, in the project development. We should follow the safety processes and the hazard analysis, the consequence analysis, and all those things, and go ahead. And I believe if we do it in a step-by-step fashion, and I think we will be there very soon.
Please, Professor,
Thank you.
Please, you don't need his hands, please still.
I just wanted to thank Mr. Day for being very optimistic, and I am also very optimistic. I think India has a great opportunity because I have been in my past 20 years. I have worked on a variety of materials, including photovoltaics, and I am really pained by India missing the silicon bus. We missed silicon bus, and that was a big missed opportunity. I don't think we should miss this bus. And that is where it's important to recognize all the challenges and work on them in tandem. And I'm very pleased to note that Indian government has taken so many steps to move in the right direction. And I'm sure we'll solve the problems one by one. And safety is something that you really highlighted very nicely. I think safety is another very important aspect of hydrogen economy. We cannot leave our citizens at the perils of disasters. So we have to ensure that we adopt mechanisms and technologies as well as intervention mechanisms so that safety is paramount and it is given due concern. But thank you very much for your positivity. I really like that.
Thank you very much. Thank you very much. Yeah.
Thank you. What I wanted to now take this conversation to, in fact, I want to talk a little more about green hydrogen's use in automobile sector, because as far as India's automobile sector is in a very interesting, exciting phase. We have CNG, we have gas, we have so many things, EVs. Now we are talking about hydrogen run vehicles. So do you think that like green hydrogen can actually be a game changer for India's automobile sector? Do you think that there is a chance that it can completely change how we are looking at automobile sector as in India? Please, Professor Garg, go ahead.
So this is, I'm sorry to jump in front of everyone, but this is something, a favorite topic of my mind. There is a lot of talk about transforming the transportation sector, both on surface as well as in air and water. And right now, we all have been guzzling all sorts of fossil fuels, and electric vehicles right now are the talk of the town. And rightly so, they have a lot of advantages. Because I mean, the first major advantage is the kind of losses that you see in diesel or gasoline run vehicle, they are not present in electric run vehicles. So I don't know if you have driven an electric vehicle, but the pickup or the torque of electric vehicles is excellent. So, and it's noiseless. It doesn't have any pollution, it's noiseless. However, the major problem with electric vehicle at the moment is the cost of battery, which is primarily lithium-ion battery. And while the research is still on sodium-ion batteries, aluminum-ion batteries, magnesium-ion batteries, lithium will remain in picture for years to come. And India is not very favorably placed in terms of lithium technology, because lithium is something which has to be imported from China primarily, but from maybe from other countries as well. Another problem with lithium is that most of the deposits in Earth's crust are very lean. So when you do mining of lean ores to extract a lot of lithium, which means you have to mine more and more. And when you mine more and more, you create more and more environmental disasters. So it's a chicken and egg problem. You require a lot of lithium and you will end up destroying environment or ecosystem to a large extent. And this is where I think hydrogen can be really, really good technology. Also, another advantage of hydrogen is if you are able to store and compress hydrogen, large volume of hydrogen in a good storage system, there is a possibility to have large mileage in the car without having to charge it or recharge it more often. So this is where hydrogen can play a very important role, because hydrogen can really give you an upper edge in terms of power, in terms of efficiency. Well, efficiency wise, maybe battery systems will be better, but electric systems are sort of better as compared to other systems, but still they will be very useful. But I think the problem right now is the cost of hydrogen. As we know, cost of hydrogen is very high. And then second, storage of hydrogen is something which is very tricky, because hydrogen is very inflammable gas. So you need to ensure that you store it very safely. People are working on a variety of materials as far as hydrogen storage is concerned. You can store hydrogen in the form of physical form, in a cylinder, or in a liquid. But liquefying hydrogen is not a mean task. It's not a simple task, because hydrogen liquefies at 20 Kelvin. 20 Kelvin is 253 degrees centigrade below 0 degrees centigrade. And if you take Kanpur temperature right now, it is 290 degrees centigrade below current temperature. So which is not a mean task, because you need to spend a lot of energy in liquefying it. So these two options are there, but they have their own challenges. People are working on storing hydrogen in the form of materials such as hydrides, such as metal organic frameworks, such as liquids, even a chemically bonded form. So if we promote R&D in terms of hydrogen storage, and are able to develop technologies domestically, which can lead to large amount of hydrogen being stored within a car in a small volume, I think that could be a game changer. Apart from that, of course, the fuel cell cost has to go down, because right now fuel cell costs are very high, and the materials which are used in fuel cells as a transporting media, as well as cathode and anode, they have to be made somewhat cheaper to make this economy work. But the statistics are sort of in favor of hydrogen if we are able to bring the costs down to a certain extent. So my take for hydrogen in India would be it gives an edge over lithium simply because lithium is not available in India, whereas we have immense possibility in hydrogen, and we are on the right track on producing it in large quantities.
Thank you, Professor. Mr. Garud, I actually wanted to come to you now because I wanted to understand just apart from automobiles, what the policymakers are very excited about. Green hydrogen becoming one solid pillar for India's energy security and self-reliance, given the volatility, like the kind of way fossil fuel prices are just going up and down. So do you think that it can be one important component for the steel, cement, or transport sectors? Like transport, he has already explained, Professor Gal, but overall steel, cement, and this heavy industry sectors, how do you think that green hydrogen can play a role? What is your take on it?
Well, I think green hydrogen is being now experimented by all the major steel manufacturers to replace the carbon, basically. carbon reduction process through coal. And most of them, of course, are using indigenous coal. But as far as the steel or cement industries are concerned, the industries have started taking a lot of efforts and interest in using hydrogen, and because it needs a shift in the manufacturing processes, in the manufacturing equipment and infrastructure. So it is something which industries need to look at. See, also, if you look at some of the recent policy developments which are likely to happen, EU is already talking of green steel. So steel produced without emissions, and they are looking at regulation which will promote use of green steel in Europe. In fact, banning the other normal steel. So those are the initiatives which will create a market, even though these processes are expensive or still under development, but they will create certain market which will pull the manufacturing into it. And I think, of course, India is one of the largest manufacturer of steel and cement in the world. And definitely the industries like Tata Steel or JSW, they are already experimenting with their facilities in Europe or in India. And we can see that it is happening. As far as transport is concerned, our bet is basically on shipping, and also the trucking and bus transport, which is for the long distances. For short distances, of course, hydrogen fuel cell, all the technologies and the safety aspects are important, and a lot of work has to be done on that. In fact, hydrogen as a fuel was not even approved by the government of India in the transport-related acts. It was only recently in 2019 or so, it was included as a fuel for transport sector. So because of the safety reasons mainly. And so that is going to be one of the challenges. The second thing, I think in the shipping also, apart from hydrogen, green ammonia, which is hydrogen and nitrogen, so basically NH4. So green ammonia can be one of the alternatives for these sectors. Although ammonia is toxic, but in the shipping it was under use earlier. And now again the shipping industry is looking at green ammonia. So shipping and aviation, these are the two industries where what we call as a hard to abate sector, because the replacement of conventional technologies or conventional fuels is challenging in these two segments, and including the industry segments as you mentioned, steel and cement. But a lot of things are happening, and we are positive that over a period of next 4 or 5 years, we will be able to see the changes.
Thank you, Mr. Garud. Actually, this is a very interesting take, because I'll be very honest, while I was researching about this subject, I was looking at a lot of comments that government departments, the policymakers, or the industry players are making. So, okay, what I want to now understand is that over the last few months, we have seen a lot of research, we have seen a lot of comments, we have also seen a lot of players, government and private players joining hands, the government departments talking about it. Where does this take India on the green hydrogen map? How these collaborations are going to work out? Mr. Day, if you can take it up, because I'm just putting it on you because you are.
Yeah, no, thank you for that. Actually, if I could just touch upon what Professor Ashish and Mr. Shirish said on the earlier part of it, actually, in terms of the common passenger vehicles using hydrogen as a fuel, I believe currently the EVs are a little bit on a lead, although lithium-ion batteries are there, maybe a little bit of a pain. But then hydrogen, the transporting hydrogen can become an issue, actually, going to the service stations or to the refill centers and all those things. So that the supply chain part of it, the whole distribution part of it, I think there still lies. I know in Australia and UK and some of the European countries, they are really gunning for it. Basically, probably they have more control. And in terms of the overall population of cars, maybe limited in a country like India, where it is extremely deregulated in terms of the number of vehicles you have and where you can have what. So it might still be a challenge, but I would not. But yes, for the long distance transportation, like the heavy vehicles, heavy transport, shipping, especially in the form of ammonia, looks to be a promising, because I believe, and also as a bunkering fuel, especially in Singapore, which is a center basically, again, ship to ship transfer of ammonia as a fuel is quite promising. And large trading houses like Sumitomo and all those people, they are doing a huge amount of money they are spending on research actually to get those things in line. So I believe if you give a time horizon, as Mr. Shiri said, of 4 to 5 years, we will see those realities. And those are the real sectors, actually the cement, steel, and we are sitting on the top of those. And if you see, and in terms of, there was a mention of that we have, the word was, we have to make some changes within the existing plants, which is nothing but repurposing the existing plants actually. So even the ammonia plants, the fertilizer plants actually, an element of repurposing has to be done even in steel, automobile, and in ammonia basically, so that we can introduce seamlessly green hydrogen into the system and green ammonia into the system basically, and to seamlessly produce the ultimate, the production basically. So that is something where I see a lot of light. And if you see a few days back, I was attending another talk show where our ammonia plants, fertilizer plants are quite energy efficient. They're almost at the top in the world basically now. Most of it, 99%, being converted to natural gas. So we have attained that level of international class of energy efficiency. So I believe we are in the right phase to introduce green ammonia into it, and then see the next phase of development and next phase of optimization. So that's something we all are looking forward to. So, and coming back to your question, Mayank, if you can once again, please repeat quickly, I'll just catch up from there.
The way industry and government is joining hands is very exciting. The way they are very excited about green hydrogen. And we have answered part of it, that where we are on the green hydrogen map, you was like literally saying that we are on the cusp and we are ready to do that. So if you just want to shed a little more light on that,
yeah. If you see, there are a number of study centers, basically CII, FICCI, and so many other people are having working groups who are working on each and every aspect of hydrogen, not only broadly on hydrogen, but its application into passenger vehicles, application into other sectors, basically. So I believe there is a lot of effort going on at the background. And yes, industry, both private and public sectors, are investing a lot of time and money and resource and capital into it, basically, in trying to see how we can make it a reality. Now, putting everything together, I believe my only caution is that we should maintain this momentum of having such forums, of having working groups, setting up pilot plans, demonstrable plans, basically. Some people taking the leap of faith of moving into the next phase, not really of course, business, money, profitability, all of this counts, but we have to take this leap. And I think the government and the regulatory arm of this country are providing us a right kind of a platform to pitch in and move. And I can see for the first time, we used to always talk about America, where the educational institutions and the government and the R&D, they work in tandem. I'm very happy to see now that, yes, this is it is getting more pronounced in India, basically, where the academia, industry, the government, all are coming together towards this. And I believe it is being done for one and only one reason. It's for our survival, basically. We want to maintain ourselves within that 1.5 degrees centigrade, basically. So I think we are moving in the right direction. And there are several statistics available, which I don't want to speak out here. And it is changing every day. It is changing every day or every week. To be realistic, yes, every month it is changing. Our perspective and our estimation of what we are going to do at what time and in which year, those are changing. I believe there's a correct and the right momentum at this point of view, and we should continue with this momentum and never let this really slow down in any way, so that we can achieve the ultimate goal of net zero.
Thank you, Mr. Day. Thank you so much. I like listening to all three of you. I'm feeling like that I have so much of homework to do, and I have so much to understand and work on. Anyways, that brings me to the next question, which you also touched upon during your introductory remarks. Uh, you know, the whole renewable energy sector in India, is not finance has actually been a thorn in the growth of RE sector. So, and you touched upon the criticality of finance for the green hydrogen sector. How do you look at this whole finance sector, and do you think that the finance is coming easy, or how what is your take on the finance part of the green hydrogen sector? That do you think there is enough money to push it?
There is money is never enough for money, actually. So if you see, the Indian banking sector has a crucial role to play, actually, if you see in tackling the climate change. Now, and few Indian banks have begun to factor climate change into their business strategies. Going forward, there will be banking institutions who will be required to disclose the levels of financing for the renewables. I believe it will be coming at some point in time, or else there is no way out. These are not that. It is not my wish, but these are my expectations that at some point in time, this is going to happen. And to an extent, with some financial institutions, it is already happening, actually. And keeping in view the enhanced target of 175 gigawatt in the current year to 450 and 500 in 2030, the overall debt servicing is large, and reducing the overall financing cost for developers will play a very important role. There is no way out for them. And if you see from the point of view of production of, again, high-tech, low-cost environment which India provides, and the renewable energy market which the India is providing because of its vastness, the land, and thank God for the sun, actually. If we can start producing electrolyzers successfully with all the challenges which Professor mentioned, and if we can start exporting them back to the high-cost countries like the European countries and the American countries, we will have a sort of, we can get finance from those European countries which are extremely competitive compared to what it is in India. So what we should do is that we should play on our strengths today, actually, producing good quality engineers, conventional engineers, creating an environment where we can manufacture, making it demanding for the rich nations to come and invest, bring their finances at a very, very competitive rate, which we can never even dream of, basically, producing those and sending it back to those countries. Now, if we, that is one part in terms of manufacturing, basically. In terms of production of green ammonia, if you look at green hydrogen, if we cannot afford it at $4 per kg today, and if we can produce that abundantly, there are ways to export it to other countries, basically. And we continue to do with our conventional and slowly get into the blending route and build ourselves to get a complete 100% transition. But we can play the other route of making it a playground where we are the manufacturers of hydrogen, manufacturers of ammonia, manufacturers of the equipment and parts, basically a field for R&D, and then do it in a reverse way, basically. So I believe this is the way. There are many ways to solve this puzzle, but from whatever I have heard and whatever I've understood, this can be one of the ways, basically, in which we can, bring about this tussle, this constraint of finance within our country in the setup.
Thank you. That helps my cause. Mr. Garud and Professor Garg, do you want to also have a go at this question before we open it for audience? Because otherwise, we'll be running late.
I mean, I'm broadly in agreement with what Mr. Day was saying, and I think both green ammonia as well as green hydrogen can power the whole hydrogen ecosystem. And I agree with Mr. Day in the sense that if we can develop the manufacturing capability in India, then we can actually be exporters to many countries from whom we are taking things, and we have live examples in many things. I mean, India has done so in many sectors, so there is no reason why we can't do that. So from the importer, if we can become exporter, I think we will win the game.
Mr. Garud?
Yeah, I also agree with both of them. I think another important factor is the changing image of India with respect to doing business or bringing investments. So what we have seen in the renewables, we are attracting large amount of international funds in the renewable energy sector. So it's not only Indian banks, or Indian funds, but as Mr. Day mentioned, the European funds or the funds from developed countries, which are much cheaper than our internal funding, in terms of interest rates and all, and pension funds or bonds. So there is a variety of funding available, and I think India's credibility to service the loans, to develop the quality projects and give the desired output, that has been established, and it has improved over the image has improved over last 7-8 years, and that is something which is very encouraging for the new technologies or new business ventures. And with the startup culture and promoting Indian industry through schemes like PLI and all. So the manufacturers and the manufacturing with the financing for all these activities, I believe will be available from the global community. And with our ambitious targets, that is going to be a major market. And plus, what is happening with the Chinese Chinese manufacturing, people are looking at not putting all the eggs in one basket. So they are looking at options, and India, with quality of education, the quality of engineers and infrastructure which we have, soon we will be entering into 5G era. So we are actually ready to absorb, ready to offer those kind of quality infrastructure to the global community for investments. And I think that is where hydrogen also will be an attractive sector for investments.
Agreed.
Thank you so much, Mr. Garud. In fact, now we have, I can go on. In fact, it's very exciting for me. And it's also a rare occurrence that all the three panelists or all the panelists on the webinar are like complete in consensus and positive about how we are going forward. Thank you so much. We have a few questions from the audience. I think we'll start from the gentleman called Mr. Akash Gupta. He's asking that, do climatic conditions affect production of green hydrogen? Like Niti Aayog CEO Amitabh Kant said, that we can be the largest producer of green hydrogen because India has best suited climate for it. Mr. Garud, if you want to.
Yeah, see, the climatic conditions refer here to the availability of renewable energy. And we are one of the solar rich country, and we have fairly good amount of wind resources available. Even in biomass, also we have a huge amount of biomass, surplus biomass available, which can be used for hydrogen production. So from that perspective, I think what Niti Aayog had said, that we are best suited country because we have good resources, renewable resources around the year. In the monsoon, when solar is less, we have wind resources. So that way, we have around the year good availability of renewable energy resources.
Perfect. Mr. Gupta has also asked another question. He's asking that, is there a sector in which hydrogen can be used extensively, replacing conventional fuels? I think you all have answered that, but if you want to just add a couple of lines. Anybody, any one of you, if who wants to take it.
I mean, I just wanted to add that, most energy guzzling sectors are manufacturing of metals, because we convert ore into a metal. So that's a heavily energy consuming. Second is construction industry, cement industry, including construction industry. And I mean, we sometimes forget that it's not only cement production, but also construction, which leads to a lot of consumption of energy. So that is why I'm clubbing cement with construction. And also it's not about buildings only, it's about highways and everything that we are rapidly making. And third is, I think, chemical industry, which India has a lot of it. I mean, India is very well endowed with chemical industry, and of course, transportation industry. These are four major industries which I think can benefit a lot from hydrogen as a source of energy. But again, hydrogen also has to be made from some type of electricity. So, which means we need to have continuous investments and lowering of cost in electricity that is produced from renewable energy sources, because it won't be a good thing to produce electricity from fossil and then make hydrogen, then use hydrogen to power these things. So I think renewable energy is the way out in these sectors using hydrogen.
I should tell you that we have a very excited audience. I have 5-6 questions. I'll go through them quickly so that we don't, miss any of them. So Mr. Pranjal Singh is there. He's asking that is it realistic, feasible to use steel, cement, etc. plants for demand side management of energy production? Professor Garg, Mr.
Yeah,
Green.
I think you see, these are as Professor mentioned, these are energy guzzling sectors, and I don't know what exactly he means by demand side management. Whether typically it is in terms of electricity demand side management, and if you are looking at overall energy demand for energy of these sectors, hydrogen can play a good role in the management of energy.
Okay.
Yeah, and to say these are the real push, actually, the demand which will be created and which makes the green hydrogen and as a fuel more and more viable. Actually, these are hard to abate sectors where we need to enter in one way or the other, in the form of ammonia, in the form of hydrogen. So there are various ways, but these are the actual real demand creators, which will make the final, differentiation, the differentiator in terms of the overall cost of hydrogen and making it more viable. The initial ones are the startups, basically used in small sectors, testing the waters, basically. But that is where we want to be in, and where we will be, fully. We can call ourselves as we have green, because these are as Professor mentioned, these are the real guzzling industrial sectors where we want to replace the carbon footprints.
Thank you, Mr. Dey. We now have the next question from Mr. Manish Kumar. He is one of my colleagues, and he wants to ask that the Union Minister, Mr. Nitin Gadkari, recently launched India's first hydrogen car, which is already available in foreign countries. How long do you think it will take for hydrogen-based cars to run on Indian roads?
I think it will be at least 5-6 years if we really look optimistically or realistically in this case. There will be some experimental cases, pilot projects where point-to-point services are provided through hydrogen fuel cell vehicles, typically the buses, because IOCL is experimenting with Tata Motors for hydrogen fuel cell buses in Delhi and Leh Ladakh, in some of these areas where it will be public transport service from one point to another point on the specific route where hydrogen availability can be ensured. But running, vehicles owned by public, like private owned vehicles and all, I think that is going to be a little longer game, because A, infrastructure need to be developed, and B, the vehicles need to be available. Although Tata, the Toyota Mirai is being talked about, but it is only one vehicle in the country, and they don't have manufacturing plan as such. So it will be very expensive vehicles. So very few people can afford it. So that is going to be a challenge in the beginning, at least.
Certainly.
So
we have another question from Mr. Vishal, who is asking that Vishal Falke. He's asking that please compare the bio-CNG sector with hydrogen fuel. Interesting one, yeah.
Well, quite interesting, because bio-CNG is now picking up with the government announcing the Satat scheme. They are planning to have 5,000 bio-CNG biogas plants of larger capacities running on various feed material like municipal solid waste or cow dung, etc. But and that is yet to start. I mean, there are a few plants announced and a couple of plants being installed and all. So bio-CNG in that respect is going to be an easier option, because after all, we do have a well-developed CNG network infrastructure and piping network in at least in the urban areas. So bio-CNG will definitely have some lead in terms of use of CNG, bio-CNG as a transport fuel over hydrogen in coming future.
Uh, I think, Professor Garg, the next question is for you from Mr. Kaushik Saha. Mr. Kaushik is asking that cost of metals or cost of electrolyzers are issues, but water chemistry is also an important aspect. What is our panelists' opinion on seawater electrolysis, which may be a potential solution to grid scale production hydrogen energy without reliance on fresh water?
No, I'm sure, yeah. So in electrolysis, water is an issue, and seawater could potentially be an alternative. There is a possibility. People, I think, are researching it, but I don't think we have a broad consensus as yet, because seawater also brings. See, when you have electrolyzers, you also have an issue of corrosion. So how do you overcome the issue of corrosion and degradation of components? That becomes a problem, because you have various metal connections, and all those metal connections, if there's a leakage and things like that, so you have issues. But that could be a possibility. I'm not ruling it out, but I think the word is not yet out. There are various possibilities that are being looked at, and among this is definitely an option.
Thank you. Thank you. We have one from Mr. Pavan Verma. Pavan is asking, which product is more suitable for Indian market, green hydrogen or ammonia? I think, Mr. Day, it is for you.
I mean, one is a derivative for the other. Actually, you mix with nitrogen and you get ammonia. So and it's in the process. It's in the assembly line. Actually, you produce hydrogen and then you go and get nitrogen from the PSA plant, and NH3 is ammonia, basically 3:1. So both are attractive options. Both have market in India, and it's like you produce one, the other becomes viable actually as you go forward, because for ammonia there's a large infrastructure. The ammonia loop, which is the thin loop, basically, it's an age-old process, Haber-Bosch process, basically, which is existing in the world for more than 100 years. Now, if I can get green hydrogen from anywhere in India at a viable and a competitive rate, and repurposing the plant, it's easy to turn it into green ammonia, basically. So one will drive the other, and I don't think there's any competition between hydrogen and ammonia, because even for as a fuel, we'll use ammonia to carry as a carrier for hydrogen, basically, because of its chemical characteristics. We'll use ammonia as a carrying medium. So both go hand in hand, and if you can really give me green ammonia, I will make the world green, actually. And whether it is in terms of transportation or any other hard to abate sectors, producing ammonia and bringing down our fertilizer bills, which is nothing but number 2 after the defense in the Indian budget, basically. So these are all important elements, basically. So for me, both are same. One brings the other, actually, today.
Thank you. Thank you. We have one from Mr. Suresh Kumar. He's asking, why can't we go for blending of hydrogen with the existing available fuels?
Well, there is one way we are doing it with blending of hydrogen with CNG. So yes. HCNG, and up to 18% of hydrogen blending can happen where existing infrastructure can be used. Beyond that, then as Professor mentioned, the various problems of corrosion or brittlement, etc., start with the piping and all. So yes, that is happening, and that is one of the low-hanging fruits, actually, because all the existing infrastructure is available. You just have to produce hydrogen and mix it with the CNG.
I believe that is the first step of getting in a commercial space, actually, getting green hydrogen, actually. So the blending is the first step, where you start with 8% and you can go, as Mr. Shirish said, up to 18 to 20% without changing anything into the existing infrastructure and pipelines. Beyond that, you have to look at the metallurgy, you have to look at the fittings, you have to look at the temperatures, you have to look at the leak detections, and so on and so forth, actually. But yes, up to 18 to 20%. I believe some IOCL is already, Indian Oil Corporation is already trying to do something. And that is a way how you will still be using rendering the existing infrastructure which we have built over the last 70 odd years, 70 plus years in use, basically. We just cannot throw away all the infrastructure and get the new infrastructure where it is nowhere viable or practical, actually. So that's the only way to get into the new energy zone.
Thank you. I have last 3 questions. I'll go very fast because we are running out of time. We have a question from Mr. Shashwat Datta. Mr. Datta is asking, won't it be less efficient if we convert green hydrogen back into electricity?
Well, I mean, that is a problem if you're producing hydrogen from electricity. Okay, hydrogen production has certain efficiency. So basically you use electricity to produce hydrogen, and then you use hydrogen as a fuel to produce electricity. So, you know, the same thing you do with petroleum also, right? There is a lot of industry which is also used in producing petroleum, but then the same petroleum or coal is used to produce electricity. So whichever way you look at, any fuel production will require consumption of electricity as well as production of electricity. Here we are banking our bet on producing hydrogen from energy which is renewable. The idea is to produce carbon neutrality or no emissions at all. So while in other processes, the processes may be thermodynamically more efficient, maybe, at the same time, the cost to environment is very high. In this case, the cost to environment is low. And if we can develop electrolyzers with higher capacity from, let's say, 1 megawatt to 10 megawatts or 20 megawatts, the efficiency of the system also goes up. So efficiency of system will go up if we do scale up. And as a result, the losses will also reduce. So when we build this economy of scale, the more of the possibility is definitely of improving the efficiency of the process further. But the bigger thrust is on reducing the carbon emission as of now.
Thank you. We have one from Mr. Akarsh Gupta. He's asking, in producing green hydrogen, DISCOMs can play a role, like they can use their RPOs to produce green hydrogen. Are DISCOMs having positive attitude regarding green hydrogen? Is there a positive attitude among DISCOMs about that?
Well, there's a only beginning phase so far. So let us see how it develops. But yes, DISCOMs have 2 advantages actually. One is, of course, they can get the RPOs, for green hydrogen electricity used for green hydrogen. The second aspect is also there are certain states which are coming out with green electricity tariffs. So special tariff for green electricity to be used by industries particularly. So that is something which can be attractive for the DISCOMs. And so I believe there will be a positive response from the DISCOMs for this, the new policy about green hydrogen. There should be, but
Thank
it's
you.
too early to say about it. Thank you.
Yeah. No, I understand. I understand your. Sorry, I'm running out of time. I'm taking the last question before we finish the session for today. I'm so sorry, I can't take more questions. This is an anonymous one. Do you think electrified highway lanes like in Germany or roll-on, roll-off railway services can replace the bulk of the demand for hydrogen fuel transportation, given their simplicity? I know, are we talking probably? Are we running much ahead of what?
First, we have to follow the lane system perfectly.
I think it's very early to make a conclusive remark on that, actually.
Yeah.
And these are the next phases. Let's get hydrogen, green hydrogen, and the first green ammonia molecules out, and let's see the market, test the waters, the regulations, safety, right, code, standards. I think once we cross this, which will be definitely 3 to 4, 5 years, basically, and definitely those are the futuristic ideas, and definitely those will come into play at some point in time in future.
Thank you, Mr. Day. I think we can't take any more questions for today. Thank you so much for your quick replies, all 3 of you.
Thank you very much.
I'm literally, I'm very grateful that you sportingly took all the questions and you have gone in depth and literally taken all the questions, especially the way people have no idea about green hydrogen. As a society, we also need to learn a lot as journalists, as researchers.
True.
And Professor Garg has already said that there's a great opportunity for engineers especially the ones that have been ignored for so long. I'm really grateful to all three of you. Thank you so much for joining us. I'm out of time. Otherwise, I would have taken more questions. Before we close, I just want to express all the gratitude and thankfulness to you. We hope that all the stakeholders involved will listen to experts like you and look at the challenges and opportunities this sector is producing or posing to us. We intend to carry forward these discussions in our stories, in our webinars to follow. Thank you so much, everyone, the panelists, my team, and the audience for joining us, for your time and patience. Have a good day, everyone. Thank you. Have a great day. Thank you.
Thank you very much for the opportunity.
Thank you. Thank you for giving us.
Thank you, Professor.
opportunity.
Thank you, Mr. Shirish.
Yeah. Thank you.
Thank you. Thank you. It was a pleasure.
Thank you,
meeting
Mr. Day.
today.
Yeah.
And
Thank you, Mr. Shirish. Thank you, Mr. Mr. Ashish. Thank you. Thank you, Mayank.
Thank you.